Hi, this is Joseph Lan again. So let's look at the mesh generation for the Pacific 3D grid. So this is the map file. Okay. So to get this map file, we first need to generate those arcs. How do we generate these arcs? Well, we basically got the global shoreline high resolution from NOAA. And of course, you can also use other databases. And that's how we got the shoreline and also the island boundaries, right? And we also downloaded the GAPCO and other DEMs and use ArcGIS to process them. So as far as the schism mesh generation is concerned, we are mostly interested in features, right? Like shelf break, like jetties, like the um, breakwaters, all those type of things. Okay, so for that purpose, we basically use ArcGIS to extract lots of isobars from the DEMs. So those are contained in global grid contours here. So one thing you notice that this is actually global file. Okay, so for the global um, DEM, we use different domains. Everything now the projection is long net, right? We generate the grid in long net. Okay, so for the global isobars, we use um, data line, international data line as cutoff. So that's why you see the maps like this. So we basically use this and guidance, generate some arcs, and then translate arcs by 360 degrees. So the international data line is now here. So we get a continuous grid instead of two pieces, across the international data line. So that's the trick we played. As a result, you can um, you can only see the isobars in the western part of the domain. Eastern part is actually evaporam. And same for if you use imagery, because projection is non-net, the imagery only shows on the left half of the domain. Okay, so that's something you can. Charles told me he used modified Robinson transformation. So yeah, you can explore those options. But for our effort, we just use long net. Okay, so those are the isobars, lots of isobars granted from global DEM. So from those DEM, from those isobars, we can try to generate arcs by creating arcs to follow those important features. For example, Japan Trench, the Tonga Trench, Aleutian Trench, etc. Right? So you basically we did that by hand. It's uh, some work, but it's doable. Okay, so you can see this. If you zoom in, you can see Japan Trench is delineated. Those are the Japan Trench here, and Mariana Trench is another one here, and the Aleutian Trench is here. Okay, let's turn this off. So that's basically we generate those large scale arcs. And another thing we did is delineate the alien region and not non-alien region. We use 4 kilometers, sometimes 1 kilometer as a boundary, right? So, and basically these arcs, those arcs are relatively close, 10-kilometer resolution, right? If you click them, any of them, you should see about 10 kilometers. So everything in degree. So zero point 0.1 is basically 10 kilometers because 1 degree is about 100 kilometers. So 0.1 is 10 kilometers. So we basically use 10 kilometers to delineate all the alien regimes. In addition, we also save some grid points, right? So otherwise, you have lots of high resolutions in those islands, and if you have a very steep bottom slopes, you may have very high resolution away from islands as well. So you end up with more loads. But the main thing is to really delineate the alien and non-alien resolution. regimes. So another thing you notice is that in most of the islands, we do not use auxiliary arcs, right? We allow the mesh to automatically, they organically transition the resolution smoothly inside the AD regimes. So if you zoom in any of those islands, you don't see any auxiliary arcs because most of the islands at the moment are resolved with a 1 to 3 kilometers resolution. So that's still okay. Even though the bottom slopes can be very steep at places. Okay. And the another thing we did, this is a demo site. This is Guam and Apra Harbor. So for Guam, we actually went there and refined the island resolution to below 1. Yeah, so this is a 100. This 0.001 is 100 meters. So below 1 kilometers already because we want to have high resolution there. So you can see in this case, if you turn on the isobus, you can see that it's actually quite steep. You can query this. This is actually 500-meter isobus already. So a little bit away from the harbor, it's already pretty steep water terrain and deep water. So this is where we actually ended the auxiliary arc. This arc is a 10-kilometer resolution, I believe, here. Yeah, no, this is actually 1 kilometer resolution, 0.01. Okay, 1 kilometer resolution. So 1 kilometer resolution is still okay at 500 meters. So we actually added this 1 kilometer resolution here around there to basically delineate the add-in and the transitional regimes, and most importantly, to make sure that you don't have very, very fine resolution, a couple 100-meter resolution in the middle of a deep ocean. So that's bad, okay? And inside this 500-meter isobus, you can see that, you have a skew element, everything, it's fine. Okay, so those are the non-add-in regimes. So you have a skew element, you can have a very, very skew element like this, no problem. Okay. So that's basically the steps you should follow if you want to refine other islands. Okay, just first pick a target resolution there, right? And if it's significantly finer than 1 kilometers, you may want to consider adding an auxiliary arc if the local bottom slope is steep. Okay, if it's very gentle, you don't need to add that because the resolution will automatically smoothly transition to the add-in regime. So you don't have a very fine resolution in the deep ocean anyway. So I just want to show you what we did for the some other places. For example, this one, you notice that we initially this is just constant, I think 5 kilometer resolutions, but in order to, this is where another place where the bottom slope is relatively steep. So we basically added final resolution to make the transition smoother. Okay, so you can see the final grade will transition smoothly. Because this is a really borderline between the add-in regime and transitional regime. So you want to resolve, you want to transition, make sure the element quality is high. It's another, but if you go to this is a shallow region, it's a non-add-in region. So you do whatever you want. You can see very skew elements here, it's fine. Okay, those skew elements are perfectly fine. So you don't need to worry about it. So it really depends on, if you are inside the non-add-in regime or the transitional regimes. So this is Tonga, near Tonga Trench, so this is another place where we locally added because again, the slope is relatively steep. So we added this enhanced the resolution in this portion of the arc so that the transition is relatively smooth. So that's essentially what we did. And again, those are the trenches. And let me think. Yeah. So the reason we added here, locally refined here is again, the steeper bottom slope. So we want to add the, but in this place is actually quite relatively shallow. So it's actually, you see lots of skew elements as well. So it's not a problem. Okay, so you really need to, when you generate a grid, when you try to decide the resolution, you really need to use this isobars as a guide. Okay, if they see if the bottom slope is steep or not. So I think that's everything I have to say about the mesh generation. If you follow this steps, you should be doing fine. Again, if you the mesh resolution is not smooth enough and you have a problem, model wouldn't blow up. Okay, you just you see this kind of spurious process coming out very quickly in a couple of days. No shorter, no longer than 7 days. So there's a problem. You could fix a mesh, locally. That's it. Thank you.